Welcome back to Inorganic Tutors Institute. In today's lecture, we are basically going to solve quiz 2 on algebra and trigonometry, right? Algebra and trigonometry, that is for 2025-2026 academic year. So basically, this quiz focuses more on asymptotic problems, right? So we have to understand or briefly understand the concept of asymptote, then we can solve these questions with efficiency, right? So first of all, an asymptote is basically a line, right, that a curve approaches arbitrarily closely but never reach. All right, that is for an asymptote. So let's take this practical example. If you are walking along a wall, right, you are getting or you get close to the wall but you never touch the wall, right? That is, in a practical sense, that is an asymptote, right? In a practical sense, that is an asymptote. So we have three types, right? We have the vertical asymptote, we have the horizontal asymptote, and we have the oblique asymptote, or what we call the slant or the diagonal asymptote. So these are the three types of asymptote. Now, with the vertical asymptote, briefly for you to get it so that we solve these questions, because we are going to have a full episode on asymptote, right? But we have to get a brief understanding of this before we solve the question. So with the vertical asymptote, it deals with a rational function, right? So for instance, if you have a rational function and you want to find the vertical asymptote, simply set the denominator to 0. Then the values of x that you obtain over there becomes your vertical asymptote. But first, what you do before you set the denominator to 0 is by checking if you can factorize either the numerator or the denominator, so that if there is any cancellation, you cancel it out before you set the denominator to 0. Great. Now, the second asymptote is the horizontal asymptote, right? So with the horizontal asymptote, it deals with three conditions. It deals with three conditions. The first condition is if the numerator or the degree of the numerator is less than the degree of the denominator, then we say that the horizontal asymptote is at y equals 0. Is at y equals 0. That is the first condition for the horizontal asymptote. The second condition is if the degree of the numerator is equal to the degree of the denominator, then we say that we find the horizontal asymptote by comparing the coefficients of the numerator to the denominator. Then you say that the horizontal asymptote is at, let's say, y equals 2 or whatever number you have, right? Thirdly, the horizontal asymptote, third condition is if the degree of the numerator is greater than the degree of the denominator, then we say that there is no horizontal asymptote. There is no horizontal asymptote. Then the third type of asymptote is oblique or diagonal or slant asymptote. That guy came in and he also gave a condition. It continued from the horizontal asymptote where he said if the degree of the numerator is greater than the degree of the denominator, then there is no horizontal asymptote. Oblique said if that is the case, then he's going to say that if the degree of the numerator is greater than the degree of the denominator just by 1, then you have oblique asymptote or slant or diagonal asymptote exists. I come again. If you want to find the oblique asymptote, the first condition or the condition you have to check is the degree of the numerator greater than the degree of the denominator just by 1. If that question is not answered, you cannot find oblique asymptote, right? So you have to always make sure that the degree of the numerator is greater than the degree of the denominator just by 1. Then you can find by either polynomial division or synthetic division. Then you get your oblique asymptote. So that is the overview of the asymptote concept. Now, we are going to look at these questions that will help us to understand it much better, right? So the first question, it says that we should find the oblique asymptote for the function h of t equals 2t squared minus t minus 7 divided by t plus 2, right? We need the oblique asymptote. Now, earlier on I said that oblique asymptote, you must make sure that the degree of the numerator is greater than the degree of the denominator just by 1. And that condition works here, right? This is 2 and this is 1. So this works. Now, we want to know the value, right? So we either use the polynomial division or the synthetic division, right? So we are going to use the polynomial division in here. So, or what we call the long division, right? So we have 2t plus 2, and then under the square root sign we have 2t squared minus t minus 7, right? So we perform our long division. We have 2t here. This goes here. We have 2t squared. We have plus 4t. There is no other term, so we put plus 0 there, right? So we perform the differences. This minus this becomes 0. This minus t minus 4t becomes minus 5t. Minus 7 minus 0 becomes minus 7, right? Then we go again. We divide this by this, right? So we have minus 5 here. Then we use the minus 5 to multiply everything. So we have minus 5t minus 10, right? So we find the differences. This minus this becomes 0. Minus 7 minus minus 10 becomes plus 3, right? So this becomes our remainder, this becomes our quotient, and this becomes our divisor. So now, which one is the oblique asymptote? The oblique asymptote is simply the quotient, right? So we say that the function now becomes h of t equals the divisor plus the quotient plus the remainder divided by the divisor, right? So this is how we write it now. Now, look at this function. We can see that if we substitute infinity here, or as t approaches infinity, we realize that this fraction will tend to 0, right? If you put infinity here, you have what? Infinity. And 3 over infinity is 0. Anything over infinity is 0. So as t approaches positive or negative infinity, we have the fraction goes to 0, and then the oblique asymptote becomes 2t minus 5. So we have y equals 2t minus 5. And that is the oblique asymptote for this particular function. Right. Now, the second question says that which of the following does not have a horizontal asymptote? Now, we stated 3 conditions for horizontal asymptote. Now, let's look at the first option. We have 3 over x minus 1, x plus 2. So this one possibly is satisfying the condition of horizontal asymptote because the degree of the numerator is less than the degree of the denominator, right? Because we have 3 here. 3 here means that we have 3x to the power 0. 0 is less than, let's say you multiply this and you have, let's say, s squared in it. It means that you are going to have y equals what? 0 for the horizontal asymptote. So this is a horizontal function, or this is it satisfies the condition for horizontal asymptote. B, realize that the degree of the numerator here is 1 and the degree of the denominator here is also 1. So the horizontal asymptote is what? Y equals what? 3 over 3, and that is 1, right? So this satisfies the condition for horizontal asymptote. Now, the third one is the option C. We have x minus 1 divided by 2x plus 1. We can realize that the degrees are the same, so we find the horizontal asymptote by comparing the coefficients. So we have 1 over 2 for the horizontal asymptote. So this also works. This also works. So it means the three options holds. So it means this one will not satisfy the horizontal asymptote condition. We have x cubed minus 3 divided by x squared plus 2. The degree of the numerator is greater than the degree of the denominator. So there is no horizontal asymptote. So we have no horizontal asymptote for option D. No horizontal asymptote because the degree of the denominator is greater than the degree of the denominator. The degree of the numerator is greater than the degree of the denominator. So there is no horizontal asymptote. So the right option is D. The right option is D. Now, question 3, it says that how many vertical asymptotes does the graph of this function have? So they are asking of how many, quantity, the number, right? So looking at this function, how do we get the horizontal the vertical asymptote? By setting this to 0, right? This expression to 0. So we have 2x minus 1 equals 0. This implies that x is what? Half. Set this to 0. We have 2. We are going to have negative 3 on 5. So it means that the vertical asymptote is at x equals half and then x equals negative 3 on 5. So it means we have two vertical asymptotes. We have two vertical asymptotes for this particular graph, right? So the number of asymptotes that are in this graph is 2. Is 2, right? Now, the fourth question says that which of the following has an oblique asymptote? Which of the following has an oblique asymptote? So basically, oblique asymptote says that if the degree of the numerator is greater than the degree of the denominator just by 1, then you can say that the oblique asymptote exists. So let's look at option A. Right? Option A is horizontal asymptote. So we will not consider that. Option B, degree of the numerator is greater than the degree of the denominator just by 1. So this is an oblique asymptote. This is an oblique asymptote. This is an oblique asymptote. So option B is correct. Option C is a horizontal asymptote. Option D is also a horizontal asymptote. So the correct option is option B. Right? See how simple it is if you understand the conditions and the types, how each of the asymptote works. Now, let's come back quickly for question 5 and 6. With question number 5, we want to evaluate 3 to the power x equals 5 to the power x minus 2, right? So, to be able to do this with efficiency, we have to quickly remember the laws and properties of indices and logarithm, right? So, in a nutshell, we want to make this expression, we want to make s the subject in here, right? So, remember, if you have 5 to the power x minus 2 is the same as 5 to the power x divided by 5 to the power 2, right? So, let's apply the same knowledge here. 3 to the power x is equal to 5 to the power x divided by 5 to the power 2, right? Now, in here, we can multiply both sides by 5 to the power 2, right? So, this implies that we have 5 to the power 2 times 3 to the power x equals 5 to the power x, right? We need those with the s term to be on one side and those the constant to be on one side as well. So we divide through by 3 to the power x, right? So we have 5 to the power 2 equals 5 to the power x divided by 3 to the power x. Now, we want to make s the subject. Now we have 3 to the power 5 to the power x divided by 3 to the power x. We can see that they all carry the exponent x. So we can put all in a bracket and put the exponent on top as x, right? So this implies that we have 5 to the power 2 equals 5 over 3 to the power x here. So this expression, we can easily find x now by introducing logarithm to both sides, right? So we have log 5 to the power 2 equals log 5 over 3 to the power x, right? So if we want to find x, we simply have to shift the x back. Then we have log 5 to the power 2 equals x log 5 on 3, right? And remember, in the logarithm property, we know that log 5 over 3 is the same as log 5 minus log 3, right? So this property works, right? So this implies that s is equal to log 5 minus log 3, right? Divided by this, right? S is equal to, we need x, right? We need x. So it means that we have to divide this by log 5 over 3. And we know that log 5 over 3 is log 5 minus log 3, right? So we have x is equal to 5 to the power 2 divided by log 5 minus log 3. So the final answer is x equals 2 log 5 divided by log 5 minus log 3 for this particular problem. So x is equal to 2 log 5 divided by log 5 minus log 3. So we have been able to evaluate this expression nicely by using the properties of indices and the laws of indices together with its friend, right? The colleague. So indices and logarithm, they work together, right? So that is the expression after evaluating this. Question 6. We want to decompose into its partial fraction the function f of this function t of x is equal to 7x squared plus 1 divided by x plus 3 multiplied by x minus 1 all squared, right? So how do we do this? We have to quickly think of how to do decomposition, right? So we know that 7x squared plus 1 over x plus 3 x minus 1 all squared is equivalent to a divided by x plus 3 plus b divided by x minus 1 plus c divided by x minus 1 all squared, right? So this is the decomposition, but we need the values of a, b, and c. So what do? We have to find the LCM for this, then we compare, right? So when we find the LCM for this, we are going to have s plus 3 x minus 1 all squared, right? So we can see that this will go off, then it will left with x minus 1 all squared. So we have x minus 1 all squared a plus this will take one of this, so it will be left with s plus 3 x minus 1 b plus c into s plus 3 because it will take off all this. So we have s plus 3 c, right? So in here we can see that the denominator is the same here. What we have here is the same here. So we can easily find the values of a, b, and c by comparing the numerators, right? So we're going to have 7x squared plus 1 is equal to x minus 1 all squared, a plus b, or let's write the expression for x plus 3, s minus 1, b, plus s plus 3, c, right? So we are comparing this to that, right? Now, we can do this substitution for us to get a, b, and c easily, right? So we can say that let x equals 1, right? So if x equals 1, that means if you substitute 1 here, you're going to have 0 here, right? Then it means that the a will run away or the a will vanish. If you substitute 1 here, this part will be 0. It means that the b part too will vanish. Then if you substitute 1 here, you're going to have 1 plus 3, which is 4. So you have 7 into 1 squared plus 1 is equal to 1 plus 3c. So we have 7 plus 1 is equal to 4c. So this implies that our c is equal to 8 over 4, right? And that will be equal to 2. So this implies that c is equal to what? 2. We have easily obtained the value of what? C. Now, we need b and a, right? So we can equally say that x should be equal to what? Negative 3. That is by saying that s plus 3 is equal to 0. This implies that s is what? Negative 3. So we substitute negative 3 here, and the b goes to 0 because negative 3 plus 3 with 0, 0 multiplied by everything is 0. Then we substitute negative 3 here. This will go to 0 as well. So we're left with only the a term. So we have 7 into negative 3 squared plus 1 is equal to negative 3 minus 1 all squared times a. Great. Now, 7 into negative 3 squared, we are going to have 7 into 9 plus 1 is equal to negative 3, negative 1 becomes negative 4. Negative 4 squared is 16. So we have 16a, right? We need a, so we have to make sure that we multiply this. So 63 plus 1 is 64 is equal to 16a. Now we need a, so what do? We have to divide 64 by 16. So 64 by 16, and that is 4. So this implies that our a is equal to 4, right? Now we need b, right? So we can equally say that x should be equal to 0, right? So if x is 0, we have 7 into 0 squared plus 1 is equal to 0 minus 1 all squared plus and now we know a to be what? 4. So we put the 4 there, and then plus x plus 3. So we have 0 plus 3 into 0 minus 1b plus 0 plus 3c, right? So if we expand this, we are going to have 0 here plus 1 becomes 1. And that will be equal to 0 minus 1 is minus 1. Minus 1 squared is 1. 1 times 4 is 4. Plus 0 plus 3 is 3. 3 times negative 1 is negative 3. So we have negative 3b. Plus 0 plus 3 is 3. 3 times 2 is 6, right? Because the c is 2, so we have 6 here. So it means that our b is going to be, this implies that 1 is equal to 4 plus 6 is 10, right? So we have 10 minus 3b. Now we need b, so we send this here. We are going to have minus 3b is equal to 1 minus 10. So this implies that our b is equal to minus 3 minus 9 divided by minus 3, and that is positive 3. Positive 3. So this means that our A is equal to 3, our A is equal to 4, our B is equal to 3, and our C is equal to 2. So we substitute back into the decomposed expression, and then we are going to have 4 divided by s plus 3 plus 3 divided by x minus 1 plus c, which is 2. So 2 divided by s minus 1 all squared, right? So this is the decomposed expression. This is the decomposed expression. 4 over s plus 3 over s minus 1 plus 2 over s minus 1 all squared. That is the decomposed expression. Let's quickly move on to question 7, 8, and 9. Okay, so with question number 7, we are going to evaluate this log expression, right? Now, we have to record the first property and the third property, right? Where we say that log a to the power m divided by, or let's say this one, we have this to be equal to m log a, right? And then we say that log m base m is equal to what? 1. So we are going to use these two properties to evaluate the expression, right? So this here we are going to have 2n log m base m, right? And this is 1. So we have 2n as our result. So that is the result for evaluating this. With question number 8, we want to solve for x in the equation 5 to the power 2 minus x equals 1 over 125. Now, to easily do this, we have to express both sides of the equation by the same base, right? So we know that, 1 over 125 is equal to 1 over 5 to the power 3, right? You know 5 to the power 3 is 1 over 125, right? 5 to the power 3 is 125. So this is the same as 5 to the power minus 3. So once you know that this is this, then we can equally have 5 to the power minus 2x, 5 to the power 2 minus x equals 5 to the power minus 3, right? So equating the numerators, since the bases are the same, we have 2 minus x equals minus 3. So this implies that our x is going to be 2 minus x equals to minus 3, then minus x is equal to minus 3 minus 2. This implies that our x is equal to positive 5. So the x of this expression is positive 5. So you can try it and see. We said that 1 over 125 is 5 to the power minus 3, right? So if you put 5 here, you're going to have what? 2 minus 5, and that is minus 3. So it's equal. So it is equal. So you have 5, 2 minus 5 is 5 to the power minus 3. And this is the same as 1 over 125. So perfectly, our s is positive 5. Good. Now with question number 9, we want to use this transformation from y equals absolute x to y equals 2 times absolute x minus 4 plus 1 to find the intercept of the new function. Now this is very simple, very simple. You have to understand the property, or you have to quickly recall the property of absolute values. So recall that the absolute value of x is greater than or equal to 0. No absolute value is less than 0. Once you have that, then it is impossible, right? So every absolute value is greater than or equal to 0, right? Now, what we have here, the expression or the transformation is y equals absolute x, right? So the first vertex for this is what? 0, 0, because absolute x, it is either greater or equal to what? 0. So in this case, it's going to be what? 0, right? So the vertex for this transformation is what? 0, 0. Now let's look at this. 2 times x minus 4 plus 1. 2 times x minus 4 plus 1. Now if you put, so we have 2 times x minus 4 plus 1, right? Now this 2 here basically tells you that this is a stretch, a vertical stretch, right? This is a vertical stretch. It doesn't add anything to the transformation, right? It's a vertical stretch. And x minus 2, x minus 4 implies that it's equal to 0. So this implies that s is what? 4. And this means that it is a shift to the right by 4 units. It is a shift to the right by 4 units. And plus 1 here means that 4 and 1, right? The s is 4 and the y is 1, right? Because we have a shift up by 1, we have a shift to the right by 4 units. So we have 4 and 1. So that is, so the vertices are 0, 0 and 4, 1. 0, 0 and 4, 1. Now, for us to get the intercept of the new function, that means that we have to find x-intercept and y-intercept, right? So this is just the vertices. Now we are interested in the intercept, right? Now to find the intercept, we say finding the x-intercept, we know that at the s-intercept, y is 0, right? So if y is 0, that means that we're going to have 0 equals 2 times absolute of x minus 4 plus 1, right? And this clearly tells us that we have 2 times absolute of x minus 4 equals negative 1. Can you realize that? This, if you bring this, you're going to have 2 times absolute of x minus 4 equals negative 1. And comparing this to the absolute property, this is impossible. So this is impossible. So there is no s-intercept. If you want to find the s-intercept, it is not possible, because if you equate y to 0 and you have this expression, it means that you're going to have 2 times absolute value of what? X minus 4 equals what? Negative 1. And we said that the absolute value property is supposed to be what? Greater than or equal to what? 0. And this is what? Less than 0. So it means that finding the s-intercept will be impossible. So no s-intercept. Now let's come to the y-intercept. So with the y-intercept, we are just going to make s the subject, right? So with the y-intercept, at the y-intercept, s is what? 0, right? So it means we have 2 times the absolute of what? 0 minus what? 4 plus 1 equals what? Y, right? Because we need the y-intercept, right? So we are going to have 2 times negative absolute value of what? Negative 4 plus 1 equals y. So absolute value of negative 4, you know, it is positive 4. So positive 4 times 2 becomes 8. So 8 plus 1 is equal to y. Now, this implies that our y is 9. So at the y-intercept, we have the coordinate to be 0 and 9. 0 and 9. So we have 0 and 9. So we have no s-intercept, and the y-intercept is at the point 0, 9. 0, 9. There was no s-intercept because the transformation does not satisfy the absolute value property. It is impossible at the s-intercept, but at the y-intercept we had what? 0, 9. So that is question number 9. Let's quickly move on to question number 10, 11, and 12. So with question number 10, 11, and 12, they are following one preamble, right? So it's a given the geometric sequence 6, 2, 2 on 3, and 9 on 2 up to infinity. We want to find the common ratio, right? So we need a common ratio R. So with the common ratio R, we know that we pick this 2 over 6, it should be equal to 2 over 3 divided by 2, and it should be equal to 2 over 9 divided by 2 on 3. This result, when you simplify it well, you are going to have 1 on 3, right? If you simplify 2 on 6, you are going to have 1 on 3. If you simplify 2 on 3 divided by 2, you are going to have 1 on 3. The same thing applies to this as well. So it means the common ratio R is equal to 1 on 3, right? Very, very simple. Now we want to find the value of the sequence. So how do we get the value of the sequence? So basically the value of the sequence is the end, right? The end product, right? So we use sum to infinity formula. So sum to infinity formula says that we have A over what? 1 minus R, where R is less than 1, right? So we know A to be, from the question, A is what? 6. R from the question 10 is 1 on 3, right? So we have S to infinity to be 6 over 1 minus 1 on 3, and this is equal to what? 6 divided by 2 on 3, and this is equal to 9. So we have the sum to infinity. Right. Now, we want to write an expression for Sn, right? We want to write an expression for Sn. So writing an expression for Sn, we know that the expression or the formula Sn is equal to A into 1 minus R to the power n divided by 1 minus what? R. That is the expression for Sn. So once we know this, there is nothing that is going to be difficult anymore, right? Once we know this, there is nothing that is going to be difficult anymore. We just have to substitute the value that we obtained, and then we are good to go. So our Sn will be equal to A, which is 6. So 6 into 1 minus R is 1 on 3 to the power n divided by 1 minus 1 on 3. So our Sn is equal to 6 into 1 minus 1 on 3 to the power n divided by 1 minus 1 on 3 is 2 on 3. So we have Xn to be equal to, when we reciprocate this, you are going to have 9 into 1 minus 1 on 3 to the power n multiplied by 9, right? So that is the expression for Sn. That is the expression for Sn. So Sn is equal to 9, big bracket, 1 minus 1 on 3 to the power n here. So this is Sn. So we have basically solved question 10, 11, and 12 very easily. Now let's move with question number 13, 14, and 15. We are going to use these graphs to find, to determine the type of graph that this function is possessing, right? So with this function, square root of s plus 2 minus 2, it means that the starting point is what? Minus 2. And from here, from the function again, we have a downward shift, right? Vertical, but it is down, right? So it moves down by negative 2. So it means that the point are minus 2 and what? 2. Minus 2, minus 2, right? So that is the question 13, right? That is for question number 13. The points are minus 2, minus 2. So it means that this graph starts at minus 2, because from the function s plus 2, when it sets it to 0, you get what? Minus 2. So it starts at minus 2 and it moves down to what? Minus 2. So the point is what? Minus 2, minus 2. So the correct graph is P. The correct graph is P from the sketches I have. Now, let's go at question 14. It says, J of s is equal to square root of what? S plus 2. s plus 2 goes to 0, and then we have s equals minus 2. So it means the starting point is what? Minus 2. But it doesn't have any vertical movement, right? So we have minus 2, 0. Right, we have minus 2, 0. And clearly, we can look at it from this direction here, minus 2, 0 for the Q. Right, so that is the Q for g of x is equal to square root of s plus 2. We represent the Q graph. And then question 15, g of x is equal to negative of x plus 2. So this negative here changes everything in here. So this means that it moves across x-axis. So moving across x-axis, looking at this, you can see that it moves across x-axis. So moves across, but it moves downward, right? It moves across axis, but downwards. You can see that s is negative 2. So we have it moves downwards, but across the x-axis, across the x-axis, across the x-axis. So negative 2 and what? 0, but across the x-axis. So with question 15, the correct graph is R. Looking at this graph, you can see that it is only moving upwards on the x-axis, right? So for this one, none of the functions represented the s. So the correct options or the correct graphs are P for question 13, Q for question 14, and R for question 15. Now we can easily move on to question number 16, 17, 18, and 19. Then we are down the line. We won't draw the graph here. We will draw the graph when we are talking about the asymptote in depth in the next episode. Okay, so with the last set of the question, we want to use this function to find or state the domain, vertical asymptote, horizontal asymptote, and s and y intercept, right? So when we talk about the domain is basically when the function is what? Undefined, right? It's at the point where the function is what? Undefined. It's by setting this to 0, right? The denominator to 0. So if you set the denominator to 0, you're going to have minus, this implies that when you factorize, you're going to have s plus 1 and then s minus 2. So this implies that s is equal to negative 1 or s is equal to positive 2. So the domain will be stated in this way. S is such that s belongs to all real numbers except s equals negative 1 or 2. S belongs to all real numbers except negative 1 and positive 2. Or you can equally state the domain as negative 1, 2, open bracket, union, negative infinity, negative 1, union, positive 2 to positive infinity, right? So you either state this interval notation form or use the curly bracket. So either way, it is accepted. Now, the vertical asymptote here, this is where you have to be very strategic, because the function given, you can easily factorize the numerator and factorize the denominator. And then you have some cancellation. That cancellation becomes a whole. That cancellation becomes a whole, not a vertical asymptote. So we have r of x is equal to 2x squared minus 4x divided by x squared minus x minus 2, right? And this is equal to, when you factorize the numerator, you're going to have 2x into x minus 2 divided by x minus s plus 1, s minus 2, right? So we can see clearly that s minus 2 will cancel the numerator, I cancel it, right? So cancel this and we have r of x to be equal to 2x divided by s plus 1, right? So now the vertical asymptote becomes s plus 1 equals 0. So we have x equals -1. So the vertical asymptote is at the point x equals -1. So that is the vertical asymptote, x equals -1. So that is it for question number 17. With question number 18, it says that we should find the horizontal asymptote. Now with the horizontal asymptote, since the degree of the numerator is equal to the degree of the denominator, the horizontal asymptote is at y equals 2/1 by comparing the coefficient 2/1, which is equal to 2. So that is for horizontal asymptote. Very, very easy. With the x and y intercepts, we know what to do. At the x-intercept, y is 0. So if y is 0, it means that we are going to have 0 equals 2x squared minus 4x divided by x squared minus x minus 2, right? If you cross multiply, you're going to have 2x squared minus 4x equals 0. So this implies that when you factor x out, you're going to have 0, 0. Anyway, still we have 0, right? So we have 2x out, x minus 2 equals 0. This implies that s is 0. So we have 2 of 0, right? So it means that the s-intercept, at the s-intercept, we have what? 0, 0. Because y was 0, s2 is 0. Now, at the y-intercept, x is what? 0. So if x is 0, then it means that we have to use the factorized, right? So if x is 0, we are going to have y is equal to, everything at the numerator will go to 0. So 0 divided by, this will be 0 minus 0 minus 2. And this is equal to 0 over -2, which is what? 0. So at the y-intercept, we have 0, 0. Right? So the intercept are 0, 0 and 0, 0. The intercept are 0, 0 and 0, 0. Period. That's it. That's it. Very, very easy. Very, very easy. So if you want to draw the graph, then you're going to use the vertical asymptote, the horizontal asymptote that you obtained, and the whole, then the intercept. So we have this here, we have that here. The vertical asymptote deals with the x-axis, right? So the values of x, and we had -1. So dashed line or dotted line. So we had -1, which is here. So x equals -1. And then the horizontal asymptote was y equals 2. So we have, let's say 2 is here, y equals 2, right? And then there was a hole, and the hole was 2. So if the hole is 2, x equals 2, that means if you substitute 2 into the factorized expression, you're going to have what? 4/3. And 4/3 will be the y. So we have 2, what? 4/3, which is 1.33, right? So it will be somewhere, the hole will be somewhere here. Let's say 2 is here, the hole will be somewhere here. So it means that we are going to have the intercept here and the hole will be here. So let's say the graph is moving somewhere this way, but there is a hole here. So the hole here, you are not going to pass, the line is not going to pass through, it's going to jump over it. So the line moves to that direction. So the s-intercept here and the line moves that way, right? So that is it, because the s and y-intercept all were at the origin. So we moved that way, and there was a hole here, which is 2 and then 1.33. Right? So this hole, you don't draw a line through it. It is a hole. So you don't draw a line through it. The line will jump over it and move to the next. That is it. Very, very simple on this lesson. So we will end here. Remember to share the lesson to your friends to also benefit. And I'll come back for a full episode on asymptotes. Bye-bye.